Hello everybody and welcome to page 36 in the workbook. In this video we're going to be looking at part D of this problem. Now the instructions are actually on the previous page, so let me remind you what they're saying. They're asking us to find the volume of the solid region that we obtain by rotating R2 about the line x equals 9. So what D is doing is it's describing to us a region that we're going to rotate about a particular line. Right, so let's go up to our picture over here to the right and just first find the region that we're talking about. Okay, so R2 is the two-dimensional region that's enclosed by these two curves that I'm tracing out. Y equals x to the 1/3 and x equals 4y. Okay, we'd like to take that and rotate it about the line x equals 9. Okay, so I'm going to scroll down and just so we can keep this... No, actually, I think we will scroll down just so that we've got enough room to write. Okay, and we may have to scroll up and down as we're doing this, but I'm going to just try to redraw that region R2 that we just drew. Okay, I'm going to try to draw this big enough so that you can sort of see what's going on here. Okay, so there was one of our curves and here is the other one. Okay, and that's going to get rotated about the line x equals 9. Okay, where is that in our picture? Okay, well, you can see that x equals 8 is here, so 9 is a little bit farther to the right. So our axis of rotation would actually be maybe about here. And we want to imagine taking this region now and rotating it through that line. So think of x equals 9 as being a mirror. So this point is going to come out an equal distance over here. This point is also going to do the same, kind of come out way over here. And if we draw the mirror image of that entire region, it's going to kind of look like, very roughly speaking, that. Okay. And so, again, you always, when you slice to find volume in a situation like this, you always want to slice perpendicular to the axis of rotation. So since this is our axis, we're going to be slicing left to right. Okay, and what kind of a slice do you think we're going to get here? Is it going to be a solid or is it going to have a hole in the middle? I'm kind of seeing a big gap in the middle of this, so I'm thinking we're going to get a washer when we take this slice. Okay, so something like that. Okay, and the key to finding the volume is to start by finding the area of that slice. Okay, and so here comes that important question that you've heard a couple of times. Are we seeing horizontal or vertical radii in this case? Okay, well, if we just draw one of them in, okay, the inner radius, I'm seeing a horizontal radius there. Okay, and what that means, the fact that it's horizontal, means that we need to know what x is equal to. We're interested in the x values at the two ends of that. Okay, you can see kind of from the picture that over at the right-hand endpoint, x is equal to 9, so we don't really need to do any work to figure that out. But what is x equal to over here on the other side? Okay, well, again, we've seen this a few times. That amounts to asking yourself, what curve are we on? Okay, so what's the equation of the curve that that point is on? Okay, well, the picture tells us that x is equal to 4y there. And that's already solved for x for us. We don't need to do any algebra. Okay, so we can see that x is equal to 4y there. Okay, that's going to allow us to figure out what our inner radius is. Okay, and then we'd like to know what is x equal to here. Okay, well, that curve is given by, let's sneak a peek, y equals x to the 1/3. And what do we get if we take that equation and solve it for x? We actually did this calculation, I believe, on the previous page. We cubed both sides and decided that x is equal to y cubed. Okay, so let's see if we can sneak in just, I know space is limited here. I drew that picture a little bit big, but I'm going to draw a top view of that slice. Just see if I can sneak that into our picture here. Okay, we'll start with the inner radius. Okay, so in our picture, that would be this distance here. So to get that, that's a horizontal distance, so we need to subtract these two x-coordinates. That's going to give us 9 minus 4y. Okay, and then for the bigger radius, this distance here, we need to subtract 9 and y cubed. So that's going to give us 9 minus y cubed. Okay, and so our volume, okay, let's see if we can sneak that in here, is going to be the integral of the area of that washer that we just drew. So pi times the bigger radius squared minus pi times the smaller radius squared. Okay, and the last thing we need then are limits of integration. Okay, so where do we start slicing and where do we stop slicing? Looking up at our picture, we can see that y starts out as 0 at the bottom and it ends up as 2 up here. Okay, so we're going to be integrating from 0 to 2. Okay, and that would be our answer. And one comment that I'm going to make is, because you'll see this when you're doing problems, because there's a pi in both of these answers, you could also express your answer by taking that pi and just factoring it out. Okay, so a second way of writing this integral is, I'm going to have to write this below this, pi times the integral from 0 to 2 of 9 minus y cubed squared minus 9 minus 4y squared. Okay, that's a second way that you could write your integral. Not that one way is better than the other, but just be aware, okay, that you're allowed to do algebra and simplify things if you want to.